So now we will be talking about the size of the nucleus. Now, if say suppose this is your nucleus and if we bombard this with fast moving charges or electrons say, then what we can see is that it will have a certain amount of attraction or repulsion, because depending upon the charge, it will have a certain amount of repulsion or certain amount of attraction. So now, because of this, we can have a guess as to what will be the size of the nucleus, and the process is done in such a way we will calculate the amount of deviation. If you calculate the amount of deviation, this distance will be r. So the amount of Coulombic force that these two are experiencing because of the charge will give you the radius of the nucleus. And the radius of the nucleus after your calculation was found out to be r equals to r naught into a to the power 1 by 3. R equals to r naught into a to the power 1 by 3. Where a is the mass number of, this is a nucleus mass number. We are talking about the mass number. What is the mass of the nucleus? This is mass number. And what is r? R naught is actually a constant, and the value of r naught is actually given by 1.2 into 10 to the power minus 15 meter. So what does this mean? This means that the volume of the nucleus, which is proportional to r cube, is proportional to a. Now the statement that has been given to us is that the volume of the nucleus, we are talking about the volume of the nucleus, let me use a different color. Volume of the nucleus, which is proportional to r cube, which is proportional to r cube. Now, what does this actually mean? What is volume? 4 by 3 pi r cube. This is the volume of a sphere. If you try to understand, volume of a sphere is given by 4 by 3 pi r cube. So if the volume of the nucleus, which is proportional to r cube, the more r is there, r cube, the bigger the volume will be. So this is what it is being said over here. Volume of the nucleus, which is proportional to r cube, is also proportional to a. Therefore, we can see that the density of the nucleus is a constant. Density is a constant. Now, the density won't matter because of the volume. Hence, density is a constant and this is independent of A. How densely is the nucleus, or the size of the nucleus, how densely is it populated? It is independent of its mass number. This is what it has been said to us. Now, it is true for all nuclei. Now, what is density? Density is mass, total mass upon volume. So, if this increases, this will also increase, and hence the density will be a constant. Now, why is this so? Because if r cube increases, so will A. If r increases, so will A. If r decreases, so will A. So the value, the density, what is r related to? R is related to volume, 4 by 3 pi r cube. And what is, this is volume divided by the mass. Now how is mass related? By A. So if this increases, this will increase. If this decreases, this will decrease. And so we will have a constant. Now Now this was what we can understand from the size of the nucleus. So now let's have a discussion after we had found out what is volume, what is density, so we can know what is the mass. The mass. So now it is given that the relation between mass and energy, which was given by Einstein, this is a famous relation, and this relation tells us that if you want to convert this whole mass into energy, or this whole energy into mass, and this is given by the relation, energy is equals to mc square, where m is the mass and c is the speed of light. Speed of light, and E is your energy, that energy, and this famous relation is your mass energy relation.